Now, I am going to just deal with the set of circles and the relationship between tangents and circles. Before that, you are familiar with the term tangent. Okay, now, this is a circle. See, this is a line. Both are coplanar. They are lying on the same plane. But still, there's nothing common for the circle and the line except the plane. Suppose this line is coming very close. Now, at one point it's meet. Still it is just moving. It will come close. When the line totally lies outside in the exterior, this is just a line. It has no relationship with the circle. When the line comes and just comes into contact with the circle, it touches at one point. You call it a tangent. When it still moves, when it intersects the circle at 2 points, it becomes a chord. Now, when can you say a line is a tangent or chord or neither a C chord and C? Now, you draw the perpendicular for this line. Draw the perpendicular. Draw the perpendicular. If the perpendicular distance from the center of the circle to the line, it's greater than the radius, it's neither a tangent nor a secant. Chord is nothing but a part of a secant. When you take the endpoints on the circumference, you call it chord. And when the perpendicular distance is equal to the radius, it becomes a tangent. When the perpendicular distance is less than the radius, it becomes a secant, ultimately a chord. Now, this is the relationship between a line and a circle. Now, I am going to talk about two circles. For example, these two circles touch externally each other. The centers and the point of contact where they touch, they all will be collinear. Now, if this is R1, this is R2, they are externally touching circles. Now, when two circles touch externally, you can draw a common tangent. And two circles touch externally when R1 plus R2 equal to D. D is nothing but the distance between the centers. Now, for example, this is one circle, this is one circle. They are neither touching, nor meeting, nor intersecting. One circle falls entirely in the exterior. Now, this is R1, this is R2. Whereas if you join, this is going to give you D. If R1 plus R2 is less than D, then the two circles are non-touching circles as well as non-intersecting circle, and one circle falling entirely in the exterior of the other circle. Now, if the circles are coming very close, in that case, when they touch each other, R1 plus R2 will be equal to D. Now, in this case, you can draw one tangent like this, one tangent here. That is, these tangents are direct tangents because both the centers, they are on the same side of this tangent. both the centers are on the same side. So they are direct common tangent. Also, you can draw tangents like this. So 4 tangents can be drawn for this type of circle. These two are called transverse tangents because one center lies on this side, another center lies on this side. So, if the circles do not meet at all, in that case, R1 plus R2 will be less than D. You can draw 4 common tangents, 2 direct, 2 transverse. Now, if the circles are coming very close, R1 plus R2 will be equal to D. You can draw 1 common tangent. This is also, see, one center falls on this side, one center falls on this side. You call it common tangent, and this is a transverse because both the centers fall on opposite side. Now, you can draw 3 tangents if R1 plus R2 equal to D. Now, the circle still, it comes closer, it is touching, internally they are touching. So, now, so this is the center, this is the center, this is the D, this is R1, R2. So, if R1 minus R2 equal to D, in that case, the circles are touching each other internally and there can be only one tangent. Okay? Now, these are intersecting. See, this is R1 and this is R2. Very clearly you can make out R1 plus R2 will be greater than D. So, if R1 plus R2 is greater than D, the circles are intersecting and you can draw again only 2 direct tangents, common tangents, and no other tangent can be drawn because they are intersecting. But one common chord can be drawn. One thing you should know, common chord will be perpendicular to the line of centers. Common chord will be bisected. This will not be bisected. Okay. And also, common chord, if you join to the center, in that case, the line of centers divides this quadrilateral into 2 congruent triangles. Now, here, one more thing we can see. If the circles are still coming very close, see, this is R1, this is R2. See, for example, I am having R1 as 5, this distance as 2. Now, the radius of this circle is 2 or 3, whatever it is. Now, in this case, R1 is 5, R2 is 3, distance between the centers. Now, R1 plus R2, 5 plus 3, definitely it is greater than the distance between the centers. R1 plus R2 is greater than. Now you see, here also you see the same condition. So, for externally touching or internally touching, you can find out easily R1 plus R2 because no symbol of inequality is used. But in this case, If R1 plus R2 is greater than D, immediately you cannot decide whether they are, one circle is falling entirely in the other or they are intersecting circles. If R1 plus R2 is greater than D, then you should go for R1 minus R2. See, this is R1. This is R2. Okay. Now, suppose this is 5. Okay. Now, if this is 3. This is 3. Now, distance between the centers, R1 minus R2, definitely no. This has to be, this is 5. So, distance between the centers, see, the center of this circle is this, center of this circle is this. So, definitely this will be R1 minus R2 will be less than D. Whereas, here you see R1 minus R2, this is 5 minus 3 will be either equal or less than. If R1 plus R2 is greater than D, in that case, you have to check for R1 minus R2. If it is less than D, they are intersecting. If it is greater than or equal, then it will be non-touching, one falling entirely in the other.